For most people, the heart is simple. A pump. A muscular engine pushing blood through the body, nothing more. But if that were true, one question would be almost impossible to answer. Why doesn't it wear out? Because while your skeletal muscles rest, the heart never does. Not for an hour, not for a minute, not even for a second. Before you finish watching this video, your heart will have contracted thousands of times. By the end of a lifetime, that number may exceed 3 billion beats. Without vacations, without maintenance, without replacement parts, and somehow it keeps going. But that's only part of the mystery, because your heart is not simply pumping blood. It is constantly communicating with your brain, monitoring pressure, adjusting blood flow, responding to hormones, releasing its own chemical signals, and making millions of microscopic corrections every day. In reality, the heart is far more than a pump. It is a sensory organ, an electrical organ, a hormonal organ, and one of the most extraordinary examples of biological engineering ever produced by evolution. Right now, as you listen to these words, around 5 liters of blood are circulating continuously through your body, and behind that movement lies a structure roughly the size of your fist, small enough to fit in your hand, yet powerful enough to sustain every cell in your body. The heart itself is made of specialized muscle called myocardium. Unlike skeletal muscle, which contracts only when consciously activated, cardiac muscle possesses remarkable properties that allow it to function continuously for decades. Under the microscope, the myocardium reveals an architecture unlike any other tissue. Individual cardiomyocytes are connected through structures called intercalated discs. These microscopic junctions contain gap junctions that allow electrical signals to pass directly from one cell to the next. As a result, billions of individual cells behave almost as a single coordinated unit. A living syncytium, an immense network where each contraction spreads with astonishing precision. But where does that electrical signal come from? The answer lies within a tiny cluster of cells hidden inside the right atrium, the sinoatrial node, the heart's natural pacemaker. Unlike most cells in the body, these specialized cells do not wait for instructions from the brain. They generate electrical impulses spontaneously, again and again and again. Roughly 100,000 times every day, each impulse spreads across the atria, then reaches another critical structure, the atrioventricular node. This brief pause allows the upper chambers to finish filling the ventricles before the signal continues downward. From there, electrical activity races through the bundle of His and an intricate network of Purkinje fibers. Within fractions of a second, billions of cardiomyocytes contract together, producing one heartbeat, then another and another, a perfectly synchronized electrical performance repeated throughout your entire life. But synchronization alone is not enough. Blood must move in only one direction, and that responsibility belongs to the valves. These remarkable structures contain no muscles of their own, yet they open and close with exquisite timing. The mitral valve, the tricuspid valve, the aortic valve, and the pulmonary valve. Together, they act like biological one-way gates, responding entirely to differences in pressure, preventing backflow, maintaining efficiency, and ensuring that oxygen-rich blood reaches every organ. The heart itself also has enormous demands. Despite representing only a small fraction of body mass, it consumes extraordinary amounts of oxygen, which raises an obvious question: who supplies the supplier? The answer is the coronary circulation, an intricate network of arteries that surrounds the heart like a crown, delivering oxygen and nutrients directly to the myocardium. Every cardiomyocyte depends on this constant supply, because unlike many other tissues, the heart cannot afford interruptions. Even a few minutes without oxygen can trigger irreversible damage. And yet, despite this enormous workload, cardiac muscle rarely experiences fatigue. The reason lies inside the cells themselves. Cardiomyocytes are packed with mitochondria. Nearly 1/3 of their internal volume is occupied by these microscopic power plants. They continuously generate ATP through aerobic metabolism, providing a stable and uninterrupted source of energy. The heart also relies on multiple fuel sources: fatty acids, glucose, lactate, ketones, whatever the body can provide. Its metabolism constantly adapts to changing conditions. And because the heart extracts oxygen with remarkable efficiency, it can maintain its activity year after year without exhaustion. But perhaps even more surprising is the fact that the heart constantly communicates with the nervous system. Stretch receptors located within blood vessels and the chambers of the heart monitor pressure changes every second. These signals travel to the brainstem, where complex networks coordinate responses in real time. If blood pressure falls, heart rate increases. Blood vessels constrict. Circulation is stabilized. If pressure rises too high, the opposite occurs. This dialogue never stops. Thousands of adjustments are made every hour. Maintaining a delicate equilibrium known as homeostasis, and communication is not one way. The heart itself acts as an endocrine organ. When the atria become stretched by increased blood volume, specialized cells release atrial natriuretic peptide, a hormone that travels through the bloodstream to influence the kidneys, blood vessels, and adrenal glands. Its message is simple: reduce fluid volume, promote sodium excretion, lower blood pressure, protect the circulatory system from overload. In other words, the heart is not merely responding to the body, it is issuing commands, participating directly in the regulation of internal balance. And when injury occurs, another extraordinary process begins: angiogenesis, the growth of new blood vessels. Specialized molecular signals stimulate the formation of additional capillaries to improve oxygen delivery. Although the adult heart has limited regenerative capacity, it still possesses remarkable mechanisms for adaptation and survival. Even after damage, neighboring cells remodel themselves, blood vessels reorganize, and the remaining tissue works to preserve function, because survival depends on continuity, and continuity depends on the heart. Its importance becomes painfully obvious when electrical signals fail, when valves malfunction, when coronary arteries become blocked, or when cardiomyocytes begin to die. Heart disease remains one of the leading causes of death worldwide, not because the heart is fragile, but because so much depends upon its uninterrupted activity. Every organ, every tissue, every cell, all rely on this continuous circulation. And perhaps the most astonishing fact of all is that most of the time you never notice it. You don't feel the electrical impulses, you don't perceive the valves opening and closing. You don't hear the chemical messages traveling through your bloodstream. You are unaware of the countless conversations taking place between your heart, your brain, your blood vessels, and your kidneys. Hidden beneath your ribs, an orchestra of billions of cells performs a perfectly coordinated symphony. Second after second, hour after hour, day after day, for an entire lifetime. Because the heart was never just a pump, it is an electrical network, a sensory system, a hormonal gland, a self-sustaining engine. And one of the greatest reminders that some of the most sophisticated machines in existence are not built by engineers. They are alive, and one of them has been beating inside you since before you were born.